Great. Thank you very much, Danielle. Please keep those questions coming in the Q&A box. I mean, if you want to ask a question, you can also raise your hand. I've noticed colleague Hayley Fowler has done so. If we have time, we can also try to do that in that format. But before we go to Q&A, I'd like to get a response from Tom Butcher, who is in the Met Office Business Group. And so I'm going to hand over to Tom to say a little bit about what the Met Office Business Group does and respond to some of this research that he's just heard about. So Tom, over to you.
Yep, thank you very much, and good afternoon, everyone, and thank you, Simon and Daniel, for those fascinating presentations. My role at the Met Office is I work in a group called Business Group, who work with industry customers from a spectrum of sectors, really. So these include onshore and offshore energy, they include water, aviation, consumer sectors, agriculture to an extent as well. And a large proportion of the challenge of the work that we do is in trying to build this alignment between the questions that customers are asking that relate to their needs and the questions that the science can actually answer. So I really welcome this opportunity to respond to Simon and Dan's presentations this afternoon. And it's part of that work of trying to bring those two things together so that they meet in the middle. So why are industry customers interested in the issues and the kind of science that has been presented today? As many people in the audience will appreciate, the impacts of heavy rainfall and flooding, as well as extreme heat, are two of probably the key issues that a number of businesses are trying to understand and address in their climate adaptation planning. Some of our customers are looking to understand these hazards to feed into the design of new infrastructure, and I'll mention some of this in a minute. Others are looking at it to meet regulatory reporting requirements. And also we're seeing this emerging group of businesses who are looking at climate change issues for the first time and being triggered by the requirements of things like the Task Force on Climate-Related Financial Disclosure, the TCFD. Which requires businesses to begin to integrate climate risks and progress on tackling these into their annual financial reporting cycles. I think there's also a greater why in play here, and a number of customers and staff and investors are also concerned about climate change and are now expecting that businesses are tackling it. And part of my work is about making sure that businesses remain resilient, as well as realizing, by managing risks, but also realizing new opportunities, as well as focus on that drive to net zero, which there's a lot of momentum behind now. When we think about resilience, a lot of customers think about hard adaptation measures. I call this adaptation by concrete. So this is about designing buildings and infrastructure that can withstand whatever the 21st century throws at it. And whilst that's really important, I think it's also important that businesses consider some of the more softer measures and use this kind of science to build adaptive capacity within their organizations, but perhaps by adapting how they do something, how they procure services, and thinking about how resilient their supply chain is, training staff perhaps. My favourite example of adaptive capacity, for obvious reasons, is in encouraging businesses to use weather information on a day-to-day basis more effectively in order to manage those risks. And that obviously makes a lot of sense from where we're sitting. So what are some of the key issues that businesses are facing that relate to extremes of both temperature and precipitation? Let's start with the question of extreme heat. Extremes of heat impact on large-scale infrastructure in a number of different ways. We've worked with the nuclear sector on projects over the years, really to help our customers in that sector to understand the extent to which a very extreme heat wave, a 1 in 10,000 year event, looks like, what that looks like for a coastal location in the UK throughout the 21st century. And this is really important because a nuclear reactor needs to be designed to withstand the most extreme events that can be expected. And one of the issues with this is that uncertainties in the calculations of temperature extremes, and particularly true in a conservative and safety critical environment, leads to significant costs. One of the areas where the science described by Simon might assist in this kind of methodology is in being able to understand how that heat wave evolves over the period of several days, because it's the accumulation of that heat that's important to the design of a nuclear reactor. So being able to use this kind of science in understanding that more could be really helpful to these kind of customers. Some other infrastructure type questions that we're looking at or have looked at over the last few years include risks to the rail network associated with buckling and the requirement for lower line speeds to be put in place due to heat waves. The requirement for architects to have useful data sets in order to design buildings that are going to remain comfortable over their useful lifespan. And in the energy sector, there's also issues with things like the thermal rating of equipment associated with extremes of heat. One of the problems that we're looking at the moment is how the capacity of overhead cables is lower in higher temperatures. So this is predominantly down to sagging of the cables, so the thermal expansion of the cables. So electricity network operators need to come up with new ways of adapting how they do stuff or strengthening their infrastructure and operations in order to remain resilient to these events in the future. Another advantage of the methodology that Simon describes is that he's able to easily adjust the definition of what an extreme temperature is. And this is useful and important to our work with industry, as we can then base the critical thresholds that we use in our climate studies on the analysis of past faults or case study events that we know to have caused significant impacts in the past. Another aspect to impacts associated with temperature extremes are those that are focused on human responses. Some of these relate to public health, and this will be particularly impact industries who employ outside workers such as construction, agriculture or mining. Our customers are also interested in how changes in patterns of heat wave will impact on demand. And this is a really interesting area that relates to how a business may be able to realize opportunities as well as manage those risks associated with future weather patterns. So changes to demand could be things like changes to consumer products such as barbecued food or summer fashion items. It could be changes of patterns of tourism and requirements for obviously it's sensitive at the moment, but requirements for flights into different locations at different times of the year. We also do a lot of work with the water and energy sector on demand too. I spent a few years down in Melbourne, and I flew out a week before the 2014 January heat wave, which happened to coincide with the Australian Open tennis. So we had tennis players flaking on the court and a lot of issues around that at the time. And I did some work afterwards with a retailer of air conditioning units, the equivalent essentially of Cotterill in the UK. And this really illustrated that the human impacts of climate change are sensitive not just to daytime maximum temperatures, but also to nighttime minimums. And I experienced this myself actually during this period whilst living in an unair-conditioned house. I was living basically in a shed at the time. And what's typical is that people cope with the first night of not sleeping, but after the second night of not sleeping, they go out and buy an air conditioning unit. And this is something that I experienced directly myself. So this is also backed up beautifully with the sales data from the air conditioning units. So it's worth thinking about nighttime minimums in the context of heat wave, and these are also true for other indicators such as hospital admissions or excess deaths. Coming on to think about flood risk briefly, Daniel's result around the 85% increase in days when 50 millimeters rainfall in a 24-hour period, and the map that you showed quite scary, I think, from my perspective, and probably quite a significant response result. And when we do workshops with our customers, the flooding of infrastructure, I would say, is almost invariably the number one priority for customers with large infrastructure bases. And quite often when we work with customers, we struggle to come up with the right kind of indices that are meaningful and help us to relate the climate signal back to the impacts that they're experiencing. And case studies of past events can help us establish these relevant thresholds. But we've also been looking to some of our operational forecasting colleagues, and actually a broad threshold such as 50 millimetres in a 24-hour period are often really useful, and that kind of number feeds into the sort of first pass of the National Severe Weather Warning Service. So it's good to see that relation between the climate science and what we actually experience in the day-to-day weather. Some of the additional challenges that our customers are trying to understand is the extent to which the antecedent conditions also play a part. So this can result in some quite smaller rainfall totals falling on wet ground, having significant impacts. So in summary, hopefully I've shown a couple of ways, there's a bit of a skip and a jump about, but in which the science can be useful in assisting industries in understanding heatwave and flood risk. These kind of methodologies can be applied to help industry to understand the extreme events that will impact on their infrastructure, their operations, their people, and their demand for services. And I think it's important in that context that the science is useful in identifying opportunities in some cases, as well as focusing on those risks. And these kind of methodologies can help businesses to understand the impacts of climate change. And also, one of the key features of both of the presentations is the adaptability to test the set that could be useful to test the sensitivity to their operations in different scenarios. So to finish with, I've got a couple of questions for Simon and Daniel. Firstly, Simon, I was wondering the extent to which this methodology can be adjusted to analyse the diurnal cycle. So that retail example I gave, the importance of the nighttime minimums temperatures is important on human responses to climate change. And then also, Daniel, can the analysis of precipitation be broken down on a more regional basis, taking into account the fact that extremes will vary in different parts of the country? Thank you.